What we have done up to now is to find out the solution of a differential equation. The classical method is the mathematician, what the mathematician does in differential equation circuit. What I mean, first order differential equation, solution of this differential equation has two parts, one of them homogeneous part, the other part is the particular part. We are going to calculate the homogeneous part of it and then add the particular solution to this homogeneous solution, find the final solution. That is what we have done in mathematics. Now we will be using physics, saying that the same result can be calculated in a different way. These are the natural solution and the forced solution. So general solution is the summation of those two solutions, natural and forced solutions. What are those? Let me go in a bit detail. We know this superposition. In linear circuits, we said superposition theorem is true. What it says, if there is more than one energy source within a circuit, assume that one type of energy source comes from the independent sources. It could be voltage source or current source. One of them is this. The second energy source, if we are talking about linear circuits which include inductors and capacitor in it, there is another energy source, because these L and C elements, inductors and capacitors, are energy storage elements. Energy storage elements, on the name we see that there is an energy at the beginning. So this is the other energy source. This energy source comes from the initial condition of these inductors and capacitors. So I come back to superposition theorem now. We are saying when we deactivated independent sources and the only energy source in the circuit is the inductors currents and capacitor voltages, that means initial conditions related energy, there is a solution. This solution has a special name, we call it natural solution. And the other energy source is initial conditions are zero, there is no stored energy within the circuit. Then independent sources are in the circuit, so this is the second energy source. Because of this energy, there is going to be energy distribution in the circuit. We are going to find a solution to the circuit. Now we are saying when both these energy sources are in, the previously found solution's summation is the final solution. This is the one that we found in mathematics. But we found two different term summation in this case. In mathematics, it was homogeneous part plus the particular solution. In here, natural solution plus the forced solution. So if we give the example, you're going to understand it much better. So let's see this now on the breadboard. Let me take this out. Take this in and clear this. Make it big one. So this is the circuit that we have. In this circuit, we've got two energy sources. One of them is this independent voltage source, and the other one, the energy source, comes from this inductor. So this energy is that, let's make V equal 1/2 IL0 square L times IL square. Energy source 1. The other energy source is that independent voltage source, Vs. So we are saying now the first we are going to calculate, which is called natural solution. Let me write it here. Which comes from this. The solution is going to be IL natural, we are going to call it. We are trying to find this solution. That is the second one. It is called forced solution because of that one. We will explain this later on. So how I'm going to calculate this? We said if we use the superposition theorem, so we are going to consider that Vs, independent voltage sources, will be deactivated, and only the initial condition in the circuit find the solution. So when deactivated, our circuit is going to be like this: short circuit, a resistor R, and inductor L. This is R, this is L. They are in serial, so the currents are the same. If I choose a loop direction like that, so I know IR equal IL. If you write the current law equation for this node, you get this. You remember that the serial elements currents are the same, so that is another way of explaining it. And if you write the Kirchhoff voltage law equation for this loop, then it's going to be VR plus VL equal to 0. If I use the definition relation for this one, L dIL over dt is equal minus R times ER. So definition relation of the resistor, R times ER. I know the ER equal IL, so it's going to be IL. So if you look at this now, what is this? You might remember it. Just remind you that the state equation for the circuit was this: dIL over dt is equal minus R over L IL plus Vs over F. That was the differential equation. While we are solving the differential equation, we said you're going to make that Vs equal to 0 and find the homogeneous solution. First, homogeneous plus particular. Summation of those gives you general solution, we said. Now what we are saying almost looks as if almost the same calculation of the homogeneous solution. There is a big difference. I'll explain it after this explanation now. So in this is the whole circuit. You see, I've got that differential equation. That differential equation represents this. There is no Vs in it. So I am going to find the solution for this circuit. So as we did it in homogeneous solution, we are going to estimate exponentially decreasing exponential function, and IL C times e to the power alpha t. So it has got two parameters, one of them C, the other one is alpha. Let's calculate alpha first. So since this is a solution, that means if I substitute for this equation that IL, then left hand side and right hand side should be identical. So let's do it now. Derivative of this, L times derivative is C e alpha e to the power alpha t is equal minus R. This is that estimated current, that IL. That means C e to the power alpha t. As we explained already, C is different from 0, so this disappears both sides. And e to the power alpha t is different from 0, so this and this disappears. What is left is the calculation of alpha, which is minus r over l. So my solution that I am trying to find out is this, that is IL natural is equal C e to the power minus r over lt. Now, since this differential equation represents this circuit, the solution of this, I need to calculate that C. How I am going to calculate it? I am going to use the initial condition, because we said natural solution is going to be calculated when the independent source deactivated and initial conditions are in. So that means IL0 equals 0.5 amp is in. So that is the energy source. I'm talking about representation of this energy source coming from this initial condition. So I will be using this. How I am going to use it? If you replace t with 0, then IL0, left hand side is going to be IL0, C times e to the power, when t equal to 0, that becomes 1, that's 0, so from here C is equal IL0. If I put this in here, my final natural solution is IL0 e to the power minus r over lt. This is what I am looking for. So let me do it in red. So that was the function that I am. Now I can explain you, this is not natural solution, this one. Why is that? In order to find the C value in homogeneous solution, you need to calculate that C after you found the general solution. What I mean is this. General solution of this, so you're going to find out that 0 in this equation. You're going to replace t with 0. General solution, which is the initial condition, is equal homogeneous part plus the particular part. From that, you're going to calculate that C. You've got to do it at the end. Why we are using it at the end? The end for this circuit is this, but for this circuit is not the end, isn't it? Calculation of the homogeneous solution is not the end. General solution of this circuit is the summation of those two. So I am going to calculate that C, which is inside the homogeneous part of this circuit solution, in that final solution I said. But once again, I will be using the initial condition because this circuit has got an initial condition as well. So that is different approach. So okay, we said this is a natural solution, and if you find the forced solution, I am going to explain next time. That forced solution, add them up, you get the natural solution plus the forced solution gives you the natural solution, general solution. This general solution is the general solution that you found by using the classical method that we have seen in differential equation course. So you might ask now why we have done all that. Because this circuit I am talking about, in practice it is an instrument. It is called defibrillator. So I'll show you that defibrillator now. It is this element. Zoom the frame. It's that one. This is heart attack shock equipment. When a person has a heart attack, they use this instrument to reanimate a ill person. How they do it? This part is inside this equipment, and that R represents the human body. So that is a first order circuit, isn't it? The one that we examined has got an inductor in it. This one has a capacitor. Capacitor included first order circuits examination has been left to you as an assignment. So we have done it for the inductor. So assume that there is an inductor here. Our solution is this, isn't it? So let me show it once again. Our solution is this. So this is exponentially becomes zero, that current, isn't it? So if we calculate the energy, due to the initial conditions that you are transferring the energy to human body. So this graphic tells me how this energy, so let me stop here. This energy, at the beginning, there is an energy stored here. That energy is going to start from zero. At the beginning, no connection. That means that this pallet hasn't been connected to the human body. So that means no current. That means no energy transfer. So if you touch these pallets to human body near the heart, then the energy stored here is going to be transferred to that R through the current passing through that R. So this current change is like that. So that's the energy. You could do that. In the previous one, we calculated the inductor current. From that, calculate the inductor voltage, multiply those two, and get the integral of it. You're going to end up with the energy. So if you take the energy from 0 to infinity, you're going to end up a curve like that. What this curve tells us, at the beginning, t equal to 0, e to the power 0 is 1, 1 minus 1, 0. So at the beginning there is no energy because there is no touch of these pallets to human body. When you touch it, in a short time, you're going to transfer the initial energy of this component to the human body. So this transfer has been shown with this curve. So if you look at this curve, it says these are 153 microsecond. Microsecond means 1 millionth of a second. 1 millionth of a second. So it's a very short time. 153 of them tells you maybe 190 or 200 of those 1 over 1 millionth second is that time. This is a very short time. In a very short time, you are transferring an energy to human body that reanimates this human body, and heart attack will start to run. Heart start to run. So you might say that if it is just a transfer of energy from a source to human body, why don't we directly apply this voltage source directly to human body and say somebody hold it 200 microsecond. This is something cannot be done. If we say somebody hold it for a short time like that, they cannot touch it at that length because they keep it longer than that. This is a very short time interval. So human is not that much fast to do that. Apply this 200 microsecond and take it off. This is not something that human body could do. Therefore, we need an equipment like that. because once you, at the beginning, you have the energy, you are transferring this energy to this, and then it disappears, isn't it? That is the total energy that you can transfer it. This machine does it and then stops. There is no energy to be transferred to that human body, even if you didn't take this off, because energy has gone. So, in a short time, energy transfer cannot be done by a human body, but it can be done with a machine like that. Why it is important natural solution? Because that machine is the natural solution of this circuit. So we found this circuit solution that is natural solution. That's why it is important. What does this mean? What does energy mean? If you use these numerical values, this is equal a car of which weight is 100 kilogram. If this car hits to a wall with that velocity, 250 kilometers per hour, if it stops within 7 milliseconds, that is the energy that you transferred to human body. So this is a much longer time, isn't it? So the damage on the car caused by energy release. That energy is the energy that you applied to human body, but in a very short time, not in a short time, a long time. If you apply that energy for a long time, that means human body, that human died, not because of the heart attack, but because of the electrical shock burn. He or she burns if you apply that energy for a long time. So very short time, then that is reanimation. So I gave you an example from practice that particular solution, natural solution is an important solution, a physical solution that we say in practice. There is an equipment, this equipment solution is natural solution. Let me stop this recording now.